Scientific literacy can seem like an elusive goal, even as educators, governments, and businesses try to heighten the profile and accessibility of science. Well, what's more accessible than popular culture? So, let's boldly go where no one has gone before, either in this universe on this shoe or on this tie, because this guy is just my numero uno.
Yeah, absolutely.
We're going to talk the physics of Star Trek with Lawrence Krauss, author of a book of that name. He's also the director of the Origins Project at Arizona State University and foundation professor in the School of Earth and Space Exploration. We are so appropriately attired for this discussion.
I don't know if I can concentrate without facing me.
It's pretty cool, isn't it?
Yeah,
that's
right.
a pretty cool tie.
Yeah.
Okay, hardest hitting question off the top, obviously. Star Trek or Star Wars?
Oh, Star Trek. Well, from a physics point of view, Star Trek.
Because?
Because there were so many more interesting questions. I mean, Star Wars has sort of a version of the warp drive, but after that, it's much more fantasy. I love Star Wars. I don't want to get a lot of letters. I like Star Wars, but Star Trek was kind of based on the idea that science would take us to a better future. Really, that's what's really neat about Star Trek, is it makes a presumption that somehow science ultimately led to a civilization that became more rational and more sensible, and it could explore and boldly go where no man or woman has gone before, which is, so, Star Trek is, and also, let's face it, you and I both grew up with, at least I grew up with Star Trek. I'm old enough to know the original
How
series.
old are you?
I'm 60, I'm going to be 62.
Get out of town.
I am going to
Are
be
you
60,
really?
Yeah, I'm going to be 62.
I thought we were the same age.
Yeah, I'm older than you.
You were a little bit older than I am.
Yeah.
But we both grew up with the original series. So I call myself a Trekker. Do you call yourself one?
Trekker, yeah. I'm glad to see, that's you've evolved with the times, because it was Trekkies in the original series.
Well, Trekkies are people who live in their mother's basement and
Well, I
who've
know,
never
but
kissed a girl. We're
Trekker
Trekkers.
actually is a next generation term, so you better watch yourself.
No, I'm pretty sure Trekker goes back to the day as well.
Well, we can make a bet and discover afterwards who's right.
I'm sure this is empirically provable, and we don't have to take this on faith.
And I'm not afraid to be wrong.
There are, of course, 5 or maybe even 6 different Star Trek television series over the years, and some people watching us right now will have not watched a single minute of any of them. So for those non-Trekkers, make the case as to why they ought to invest a little bit of time watching some Star Trek.
Well, because I think Star Trek, too often science fiction presents a dystopic view of the future, of one where science and technology have made civilization get worse and worse and worse. We see it all the time, Terminator, etc. And Star Trek does the opposite. It gives the notion that exploration and science can not only enhance our lives, but make it more interesting in every way. And they're fun, especially the one that, if you want to go back in time and see the old ones, as you can nowadays. It was, but what makes science fiction good science fiction is not the science. I've had this discussion with some very well-known science fiction writers. It's the fiction. The operative word in science fiction is fiction. The story has to be a good story. And Star Trek survived, I think, early on because the stories were sort of classic, right? The same stories that Greek and Roman epics were all about. And so I think it's those stories that drive things. But then there's the other thing is, Star Trek became popular around the same time as we were trying to get into space, okay, and trying to get to the moon. And I think many people today are frustrated by the fact that we last went to the moon in 1969, and we haven't left the Earth's gravity since. Humans haven't. And so the great thing about Star Trek is it allows them to imagine a universe where we can move throughout the galaxy, where people thought by now, we were doing 2001: A Space Odyssey when we were growing up, assumed by 2001 there'd be hotels in space and we'd be traveling through the solar system, at the very least, if not further. And people yearn for that because you look out at the night sky, we all do, and wonder what's out there. It's a universal human need. Having said that, by the way, I'm going to dash people's hopes because I don't think we're going to be traveling with starships through the galaxy anytime soon or potentially ever as humans. I actually think the most interesting exploration of space doesn't involve humans. Because I was going to say we've been designed, but we weren't designed. We've evolved to live on Earth. We're 100-pound bags of water. And in space, that doesn't work very well. If you want to, as I often say, you can send a rover to Mars for the price of making a movie about sending Bruce Willis to Mars. Okay?
Well said. Do you know whether or not Gene Roddenberry and all the people who wrote the Star Trek episodes actually knew anything about science?
A little bit. I mean, I think more so than more recently, where the science is often thrown in for what's called technobabble, to make it sound good or to fill a potential plot hole. And sometimes it can be pretty weird and extreme. But Roddenberry was interested, and in fact did go visit Jet Propulsion Lab, and Michael Okuda, who's one of the art directors, actually was very knowledgeable and used to read Scientific American. I've talked to him, and he has. So they were interested to try and probe what was going on at the time, and I think that's nice. But they were really creating a space western, and I think he was pretty clear about that.
Hey, you want a wagon train to the stars?
Yeah, wagon train to the stars, and it amazes me that that it's caught on and maintained itself over that time. And it's gone through ebbs and flows, but something about that, and I think it is that universal human yearning to explore and not be alone in the universe.
As you look at all the different kinds of technology that Star Trek introduced, which one do you think has the likelihood of actually happening in our lifetime?
Well, a lot of them have already happened. I mean, talking to your computers. My original phone would never have been a flip phone if it hadn't been for the Star Trek communicator. And medical imaging, the idea, when Star Trek was around, this tricorder, the idea that somehow you could probe people without opening them up was science fiction. They didn't have MRI, they didn't even have ultrasound or CAT scanning. So a lot of those aspects of technology have already come to pass. But unfortunately, the ones we really care about are the transporters.
Well, that's what I want to know. Do you think can we see a day in our lifetime where you can actually transform atoms, I guess, of people's body to energy beams and then send it somewhere else?
Unfortunately, that's one of the things that I think is impossible. There's a large difference between being impractical and being impossible. But it was the transporter that convinced me to write the book. I was thinking about it on a train trip back from New York when I'd been talking to my editor, and we made a joke about the physics of Star Trek, and then I started to think, how would I make a transporter? And I thought, wow, all this need physics. The problem is, fundamentally, a problem of quantum mechanics, because I wouldn't transport you the way the Star Trek people tell you they would. I'd take you, the way they say they do it is I decompose you to a matter stream and move your particles from here to there. Well, there's a lot of problems there. In order to decompose you into your individual particles, I'd have to heat you up to a few billion degrees and release the energy of maybe 100 nuclear weapons. It wouldn't be environmentally friendly, but I could scan you and take all the information that makes you up as a human being, transport that information from there to here, and then find some atoms already over here and make another copy of you. Now, that wouldn't be a transporter because I've copied you, but that's very simple. I'd now destroy you, and now you're only over there. The problem is, quantum mechanics tells us that there are fundamental limits. I cannot know where every atom is in your body and what it's doing at the same time. There's something called the Heisenberg uncertainty principle that tells us I can't do that. So I could make an approximation of you, but I couldn't make an exact replica. And in fact, Michael Okuda knew that, and there are Heisenberg compensators put in and they're always the things that break down when the pesky Heisenberg compensators. And some journalists asked him, how do they work? And he said, very well, thank you.
How fast is warp speed?
That's something else that had no universal aspect. If you go through the series, it kept getting renormalized, so that it used to be that warp 10 was infinite speed, but there are various episodes where they're traveling at warp 12. So the writers had to come up with some seemingly sensible system, and you may indeed have it if you have the Star Trek technical manual, and you look like the type of guy that might have it. You'll see that there was a sort of a logarithmic scale, and things get very much so. By the time you're in warp 10, you're several thousand times the speed of light. And the point is, you really need to do that, because to travel even at the speed of light, to travel to the center of the Milky Way is 30 or 40,000 light years away. So that does not make for an exciting episode. And so they had to figure out a way to do it faster. And you need to do that. Unfortunately, again, in the real world, although we can't say that, remarkably, we can't say that something like warp drive is impossible, because in fact, we have to be more careful. You can't travel through space faster than light, but space can do whatever the heck it wants, and it can expand and contract faster than the speed of light in a sense, or cause distant objects to recede. That's what's happening in our universe right now. But we're not going to have warp drive, and that means to get to even the nearest star, even if you got near the speed of light, which is not practical in near terms, if you want to travel through even the local regions of the galaxy, you're talking centuries, if not millennia. And that's probably why. Well, I do think our future's in the stars in the same sense that Star Trek might say it is. If I were going to imagine how to colonize the galaxy or even distant stars, I wouldn't send people because they don't survive easily, and who knows what's happening in centuries or millennia. But we can make people pretty easily. I'd send a computer chip with the information of how to make DNA and how to make people on a given planet, and maybe even how to educate them. So it's a lot easier to send little computers which can survive much better in space for long times without power consumption, and then make people somewhere else.
Kind of defeats the purpose, though, doesn't it?
Why?
Well, because isn't the purpose to sort of get us to explore and go
We'll
somewhere
never
else?
do it. If you and I were to go now, by the time we got it, would be our children's children's children's
Yeah.
children's children. So it's not us. So
No.
these are our progeny. We just make them by computers.
Okay.
You've got a very 20th century attitude there. You've got to get over it.
That's
Steve.
me. That's me.
Yeah.
When they talk about warp speed, what is it exactly that's being warped?
Well, again, the Star Trek people just liked the term. I mean, it was a neat term. And they said space is warping, which sounds great. But actually, what's amazing is you can imagine a way to make something like warp speed. Because if I wanted to go from here to the nearest star, it's 4 light years away. Conventional rocket ships would take 100,000 years to get there right now. But if I go out, it's imaginable that I could go out around the Earth and just turn off my rocket engines and then arrange for the space between me and the Earth to catastrophically expand, and the space between me and the nearest star to catastrophically collapse in 1 second, and 1 second later I'm now 100 miles away from the nearest star and 4 light years away from the Earth. That is possible in principle given the laws of physics.
We should work on that. That's good.
Well, first, the problem, however, the practical problems. First of all, we don't know if we could ever actually do it, but if we could, it would probably take more energy than there is mass in the universe. But even then, it doesn't allow you to get there faster than light. It's still a hook, because in order to make space contract, you have to fill it up with the right kind of material. It has what's called negative energy. And it would take you about 100,000 years to fill the space up between you and the nearest star. So you could do the experiment itself in 1 second, but it'd take you 100,000 years to prepare. So it's not.
This is very disappointing.
It is.
I thought you'd
hate
have
to
this
dash
nailed
your-
by the end of the interview.
I know. I hate to dash your hopes that way.
Can
but
I assume that because of your commitment to reason and science, that this guy is your favorite character in the show?
They are. Yeah, that guy in that show, Data, probably in the Next Generation. I think I like those characters the best. There's no doubt about that. And look, you know what? You shouldn't be disappointed that we're not going to have warp drive, or we might not be traveling to Starship, because what is amazing and what empowers me is that even though we've been confined to this planet, with our telescopes and our probes, we've been able to probe the universe out to 10 billion light years away, out to the earliest moments of the Big Bang. We are exploring the universe in our minds, in some sense, as Star Trek did with television.
If there's nothing here, you don't have to make it up. But
I won't.
When Leonard Nimoy died, did it affect you personally?
It always saddens me when any cultural figure that I grew up with dies. Absolutely. I mean, sure. Even
was
David
big, though.
Bowie, I suppose. He was a good guy, and I've after writing that book, I've spent time with a lot of characters. Bill and I did a TV show once, but Nimoy.
Bill meaning William Shatner.
Yeah, William Shatner, not yeah. But Leonard Nimoy is not someone I ever met. But his voice was wonderful, and my one Grammy nomination, which was for writing the liner notes from the music of Star Trek, in that particular CD, Leonard Nimoy starts it out with his beautiful voice. So, anyway.
Let's finish on this. You wrote, quote, "The real universe keeps providing surprises that are both grander and stranger than anything human screenwriters may come up with." You want to name one?
Well, the recent discovery of gravitational waves. We have the device that if I ever told you how to build a device for gravitational waves, you'd laugh. There's one from neutrinos, which is a Star Trek one. Neutrinos, there's an episode where Quark, who's a Ferengi, which is a civilization which, unlike our own, values money, has a gaming casino, and he gets money hand over fist because he gets hold of a device that will change the laws of probability in the vicinity, which is really good if you got a gaming casino. Las Vegas could use that. But the science officer, Dax, finds out about it by sending neutrinos through the facility and finding out that they're only coming out left-handed. Now, that sounds ridiculous. It turns out it's a terminology we particle physicists use. If a particle is moving this way and spinning in this direction, or acting as if it's spinning in this direction, we call it left-handed. And so she found that the neutrinos were only spinning one way, so there was something wrong. Well, what do we know? Neutrinos do only spin one way. They are left-handed. And I like to think of the Star Trek writers kind of sit down for a story conference and think of the stupidest thing they can come up with And it's true.
And it's true.
Truth is stranger
You know,
than
we
fiction.
got a neutrino lab 4 hours north of here.
Sudbury Neutrino Observatory, Nobel Prize associated with
Art McDonald won the Nobel.
Yeah, no, neutrinos. I've worked on neutrinos for a long time. In fact, I've been to Sudbury. They're my favorite particles in nature, not least because they have a Star Trek.
Because they're left-handed and they've got a Star Trek connection.
And and they're mysterious.
Professor Krauss, live long and prosper.
To you too.
That's Lawrence Krauss from Arizona State University. Thanks so much, Lawrence.
Great.
Sheldon, beam us up.
Help TVO create a better world through the power of learning. Visit TVO.org and make a tax-deductible donation today.